right, here's another example over here looking at the drug Lipitor that is meant to lower cholesterol level. So looking at a clinical trial of 875 randomly selected patients who received 12 milligram doses of Lipitor, 53 reported a headache as a side effect. So let's check our requirements for a confidence interval first. First, we need the independence, which has to do with the 10% rule, meaning our 53 or our 875 randomly selected patients are less than 10% of all patients who receive Lipitor. Then we have the simple random sample. So yes, over here it says randomly selected. And then the last one is the n times p hat, and the n times q hat has to be at least 10. So over here it tells us that the number of successes are 53. That's our n times p hat, which tells us the other 822 did not have headaches. So yes, that is given as well. Now we're going to construct a 90% confidence interval, and we already had calculated our critical value z star, which was 1.645. We can calculate our standard error, which is the square root of p hat times q hat over n. And putting in our sample proportion of 53 out of 875, which leaves us with 822 out of 875 failures. So that's p hat times q hat divided by our sample size of 875. Let's calculate that, and that's 0.008. So putting all that together, getting our sample proportion of 53 over 875 plus or minus our critical value times the standard error. Okay, when we subtract 53 over 875 minus 1.645 times 0.008, we end up with a lower value of 0.047, and when taking the 53 over 875 plus 1.645 times 0.08, we end up with an upper value of 0.074. And just to show you that we can do the same calculation on StatCrunch, we're going to go over to StatCrunch. We're going to go to Stat, Proportion Stats, One Sample with Summary. We're going to put in our number of successes, which was 53. Our number of observation, which is 875. We're going to do confidence interval at 0.9. We're going to hit compute, and over here it gives us our standard error of 0.008, just like we calculated it. It tells us our sample proportion of 0.06, and it gives us the lower limit of 0.047 and the upper limit of 0.074, just like we found it when we manually did it over here. So last thing we're going to do is we're going to interpret this. We would say we are 90% confident that the true proportion of people who suffer from headaches on Lipitor is between 0.047 and 0.074. So again, the 90% confidence means that if we took repeated samples from the same population, so let's say we take 100 confidence intervals, 90% of them would actually include the true population proportion and 10% would not. And one last thing I want to look at over here, going back to our example about Prop 19, there are two questions asked down here. how can I decrease the width of my confidence interval? So how can I make my confidence interval more narrow or smaller? What can I do to the confidence level, and what can I do to the sample size? So in order to make my confidence interval smaller, I can either make my confidence level smaller. So if I'm 80% confident instead of 95%, that means I only capture the middle 80%. It will make my confidence interval smaller. Or I increase my sample size, because when I increase my sample size, I get better estimates, I get smaller standard errors, and therefore I will get a smaller confidence interval. And just to illustrate this real quick, remember when we're looking at 90% confidence interval, if I make it to just capturing the middle 80%, remember the critical value is the positive value over here, which is smaller for an 80% confidence interval compared to a 90% confidence interval. And remember, our margin of error, which determines the width of our confidence interval, is a product of our z-star times the standard error, which is the p hat times q hat over n. So to make my margin of error smaller, I can either make my z-star smaller, which I do by decreasing my confidence level, or I can make my standard error smaller, which I would do by increasing my sample size, because dividing by a larger number will make my standard error get smaller.